Okay, so after measuring the absorption of this rhodamine solution, we proceeded to measure the emission of the same sample. So we moved this holder closer to the light source. So let me take this out from here. We'll bring it closer to the white light source. Okay, this hole fits well. This pair of holes, so we have one here, another there. We'll check the height if this is aligned. I need to move a little bit to the right. And you can check the height. Okay, the height is okay. And we rotate this by 90 degrees. So there is an opening in the side, so light can come from the side, illuminate the sample, and the optical fiber will collect the signal or the fluorescence of that sample. So we align here, we make sure that it's aligned at the same height. That looks good. 90 degrees, so we place the sample there. And now you can see a beautiful orange light, a beautiful fluorescence from this laser dye. Okay, so I can't observe anything. Let me increase the integration time. Let's say 50 milliseconds. Now I start observing something. Let me increase by a factor of 10 now. Okay. Now I see more. I see several peaks. And these peaks are due to the lights, to the rooms, to the lights in the room. So let me turn this off. And that should disappear. And yeah, and you can see that I still have some peaks here. These are damaged pixels on the CCD, but the spectrum is very nice. So I can increase the integration time a little more. Let's say 1000. It's hard to see from here, but I doubled my signal. Okay, so and now that the lights are on, I can see the peaks back. Okay, so when you measure the absorption of rhodamine, we get the attenuation coefficient. The attenuation coefficient, it's a function of the wavelength of light. So we have this expression 1 over L, where L is the length of your cuvette, and here we have I naught divided by I out. And this is a function of lambda, and this is a function of lambda. So you get something like that. So this is alpha, and here we have lambda. You got a curve that looks like that. There are some peaks here also, so this is not as nice like that, but it was more or less like that, where you get this peak, lambda naught. When you measure the emission though, we notice that, let me write with another color, we notice that the spectrum was shifted. You get something like that. So the peak is shifted to longer wavelengths. So let's call lambda emission, lambda E. And we call this the shift between absorption and emission. It's called Stokes shift. And we explain this Stokes shift by the energy configuration of your molecule, of the rhodamine molecule. So rhodamine, the molecule, when you look at the energy, has a function of